Welcome to Linux Containers. My name is Tomasz Borchner. Historically, containerization is not a new thing. It started decades ago with chroot functionality, where you were limited to some part of the file system. And later it was greatly improved by FreeBSD jails, where you had separate processes, separate users, separate storage. Shortly after this, also the Linux had their own interesting projects, like vServer. But that was not part of the official Linux releases for quite some time. So it was later also greatly improved by Solaris Zones, where you had its own networking, its own storage, its own processes, and it was even limited, for example, to different CPUs. So proper Linux containers started about 12 years ago with the introduction of C groups and Linux containers. So now Linux containers are basically everywhere. What is so good about Linux containers? Why they're being used so much? So with Linux containers, you have everything inside the container image. Container image is a collection of the files where you have everything that is needed for your application. All the binaries, all the libraries, all the configuration files. Because of that, Linux container images, which are like a blueprint how to run the container, they are much easier to distribute, they are much faster to deploy, so they generally consume less resources. So with container technologies, you have multiple ways how to do this separation. So you have separate process space, you have separate file system mounts, you have pseudo terminals, you have dependency packages, everything is there. And from the point of view of the operating system involved, you have multiple processes running, but they are visible to the operating system. But from one container to another, you are not able to see that there are other containers running, that there are other applications running. So it could happen that in several cases you have exactly the same process ID, so the same number, but in reality it is mapped to the different process ID. So process ID 1 here is a totally different process ID than process ID here, totally different process ID like here, and so on. So important part for the Linux containers is also a feature called Linux control groups. Initially this was developed by the two engineers from the Google and later became part of the official Linux project. Generally with Linux control groups, you are able to separate resources into multiple groups. So first resource group is the CPU, where you are able to limit CPU usage, you are able to guarantee resources, you are able to restrict where your applications are running, and so on. You have memory group, you are able to reserve memory, or you are able to limit the memory. You have the storage part, where you can limit what is the bandwidth being used for your application. You could make it so that your application will use high read speed and only slower write speed, while on the other side your database might need much faster write speeds, so you are able to do such configuration changes. Also on the network part, again, you can either allocate the bandwidth or you can limit things. So you have a lot of different ways how to manage your application. And this is actually one important and great feature of the containers, because you are able to reserve resources and you are also able to limit resources. So when you have a lot of different containers running on exactly the same host, you are able to say that you don't want any single container to consume too much of your resources. Thank you for viewing this topic.